Hi, everybody. I'm Geoff Fox, and this is Slooh.com. And we're on today with a special broadcast because of an asteroid, NEA 2014 HQ124. Wow. It's a long name. We'll explain a little bit more about that, but it is what you're looking at in the center of your screen. Not exactly a huge object, around 1,000 feet or so in diameter, or about the size of a Nimitz-class aircraft carrier. But we are interested in this particular asteroid because it is reasonably close to the Earth and because we didn't know about it until very, very recently. And this is something that we've been talking about on Slooh for a long time. Let me just set this up a little bit for you. First of all, what is Slooh? Slooh is the community telescope, slooh.com, SLOOH.com. We maintain two observatories, one in Chile, our Southern Hemisphere Observatory, and another with two telescopes in the Canary Islands, and of course, our community of amateur astronomers, many of whom meet in our clubhouse at slooh.com. It's a place where people with similar interests can come and discuss what's going on in the nighttime sky on a daily basis and coordinate what they do. You know, when the Slooh telescope points, its missions are decided by our members. Each of them gets slots to choose and then decides where we will point our telescope. I'm joined today by our Slooh astronomer, Bob Berman, and in just a moment we'll be joined by Mark Boslough, and we're going to be talking about this for the next 45 minutes or hour or so. But Bob, why don't you come on in and tell everybody what they're looking at right now in the center of the screen. It looks like a dot.
Looks like a dot, but it's awfully close. I mean, this is getting scary. You know, these asteroids, once we started looking for them more and more, it's almost like maybe we shouldn't have started looking. It's kind of like a don't ask, don't tell kind of thing.
This is not going to hit the Earth, right? I mean, this is just sort of another wake-up call as opposed to somebody charging.
Right, quite right, Jeff. But the fact that it's only a few lunar diameters away, that's pretty close astronomically. I mean, this shows us that these asteroids are, especially the near-Earth asteroids, you know, they're everywhere. They're like deer ticks or those Hare Krishna people at airports. You know, you can't get away from them. Now that we're looking and we're starting to pay attention, and we'd better pay attention because now that we know how many there are, we don't want them to sneak up on us like Chelyabinsk last February 15th and hit us.
And this is a lot larger than the asteroid that exploded in the skies over Chelyabinsk.
Oh, it sure is. That one was maybe the size of perhaps a movie theater, and this one's a fifth of a mile across, aircraft carrier size. You don't want to, even though this one's going kind of slowly, you really, that is slowly, so far as space velocities go, you really don't want it to hit you. But I'm happy we have an expert who really can tell us what the impact would be like.
Okay, and we're going to go to Mark in a second, but let me just get some nuts and bolts from you really quickly. We only discovered this on April 23rd. To me, that doesn't seem like a lot of time, Bob.
It's not a lot of time, and I wonder if we had everything in place, the sci-fi type, let's shoot it down or deflect it from its orbit, that close up, that would be challenging, I think, even in that kind of situation. So, again, this is illustrating that we must do a better job of at least knowing that they're there. The knowledge is important. I mean, we don't want to be, hysterical about this. It's enough that people are worrying about their cholesterol and things like that. You don't want to shift from hemorrhoids to asteroids all the time and make your whole life into a nervous wreck. But, we just look back to, it seems like yesterday when the dinosaurs were hit, or when Ann Hodges was struck in the leg, or when 1,000 people were injured last year, to see that it is a real threat.
Yeah. Now let's talk a little bit about threats. A lot of times people will talk about the probability of something hitting the Earth. What are the chances that we'll have another Tunguska type event, or even the kind of event that took out the dinosaurs? But maybe talking probability is not the way to go. Recently, I spoke with NASA astrophysicist David Morrison, and he spoke specifically about these probabilities. Do we have that David Morrison video, Michael? I know. Well, maybe we won't have the David Morrison video. We'll come back and have that in just a few minutes. Let's bring in Michael Boslough. Michael is an experimental and computational physicist, and your research interests range from nuclear explosions to climate change, and you're here to talk more about the impact, because an object like 2014 HQ124 can have a pretty large impact on our planet.
Hi, yes, it's Mark Boslough here, and I've been interested in all sorts of big catastrophic type events, and of course the biggest catastrophe you can have is a planetary impact. This is not a super large one, you call it the beast, but there are much bigger ones. We've discovered most of the ones greater than 1 kilometer. This one would definitely be catastrophic if it hit the Earth. It would hit. It's moving at a relative speed of 14 kilometers per second, but if it were headed towards us, gravity would speed it up, and it would hit the Earth with a speed of about 18 kilometers per second. And our best estimate of the size, if it's a solid piece of rock, would lead to an explosion of about 2,000 megatons, so an enormous explosion. So if it hit a city, it would definitely wipe out an entire metropolitan area.
Wow, that's really impressive. Bob Berman here talking with you, and you consider that a megaton, just to remind everybody, is one big hydrogen bomb. The blasts over Hiroshima, if I remember right, were something in the order of 30 or 45 kilotons, thousands of tons of TNT.
Yeah, it was actually more like 15 kilotons.
So here we're talking about 1 million tons of TNT, right. And that's one, and this is 2,000. You're saying 2,000 1 megaton hydrogen bombs, that would do a city many times over.
That's right, and you'd end up with a crater about 3 miles across, and you'd be breaking. An event like that would break windows over 100 kilometers away.
Wow, that would really depress property values.
Absolutely.
So, fortunately, this is missing us. But when you see things like this coming, what is your biggest concern about the unknown ones? I mean, realistically.
Well, earlier in the program, you mentioned that it would be really hard to deflect if you only discovered it, like this one 6 weeks before impact. I mean, this one's not going to impact, but it's making its close approach about 6 weeks after discovery, if it had been on a collision course, not only it wouldn't just be hard to do, it would be impossible to do. You couldn't do anything about it except calculate where it would hit and evacuate that area. And basically, you'd have to sacrifice infrastructure, but in most cases, as long as there are telescopes and surveys in place designed to look for approaches of objects like this, you could find it with sufficient warning to evacuate people.
Well, that's a relief anyway. You could take the cat even. You'd have time to grab everything you wanted and leave the area. That's a little reassuring.
Well, yeah. Ultimately, it would be more like a hurricane event. I mean, it would cause complete destruction over a larger area, but you could get people out.
And could we predict that accurately where it would be?
Oh, yes. Yes. I mean, we have very precise numbers on this particular one. You were able to find it, and as it gets closer and closer, it'll get within radar distance, and once it's within radar distance, the precision is remarkably good on its position and speed, and the folks at JPL would be able to predict its impact point to within the nearest kilometer and its time to within the nearest second. So the prediction would be much better than a hurricane prediction. What we wouldn't know, though, is exactly how big the explosion would be, because we still wouldn't know its precise mass.
Well, knowing human nature and, the storm chasers and all that, and we always want to see what's happening. The police always say, move on, there's nothing to see here. But we know that whenever they say that, it's just the opposite. There is something to see there. So do you think in that case there would be people heading the opposite way toward the point of impact, not coming too close, of course, because you don't want to get killed, but coming at a distance where you could actually see the spectacle?
Well, I would probably be the first one headed towards the location. I'd be wanting to set up scientific instruments. I'd be all over it, but not from too close.
Well, at least you.
But I do suspect, yeah. I've brought this up before.
At least the traffic would be going the other way. You'd probably have no problem driving toward the.
Well, but I do. I would be concerned, and I think that the emergency management folks really would have to worry about, looky-loos and tourists and people who want to see it, because this would be, one of the most spectacular natural events in human history, and probably the most spectacular event, and predicted very precisely. So that would be a concern, and that's probably something that emergency management folks need to consider when they write their playbook of what they would do.
Well, this is an original line of thought. I don't think we've ever in these discussions talked about that aspect of people deliberately heading in the direction of the impact zone to see what there was to see. It's a fascinating aspect of it.
Can we talk a bit about how this was discovered? Because, correct me if I'm wrong, we're sort of lucky we even know that this object is there.
That's right. I mean, it was discovered by NEOWISE, which is the Near-Earth Object Wide-Angle Infrared, what's it stand for? Survey Experiment, I think. Sorry if I got that wrong. But it's an orbiting
wide field infrared survey explorer. Near-Earth Object Wide Field Infrared Survey Explorer.
Thank you for that correction.
I have it written in front of me.
Yeah, and I should have done that too. But so that's an orbiting telescope, infrared telescope, that's looking at the sky, and it's up above the atmosphere. The problem with infrared telescopes on the surface of the Earth is the Earth's atmosphere absorbs a lot of infrared radiation, but once you get above the atmosphere, you can see these things. And you can see them because they're warm, because the sun heats them up and they radiate in the infrared. And so this one was discovered by NEOWISE. And in fact, NEOWISE is discovering a lot of these objects. It's a very effective survey.
And is it going to stay on? Because I know that it was shut down for a long period of time, and now has been restarted sort of temporarily, right?
Yeah, I know it's got a limited lifetime, but I don't know what the lifetime is. But I do know that when it is on and when it is looking for asteroids, it does find a lot of them, and it's different. It's a very complementary method to Earth-based surveys in that it's looking off in a different direction. It's looking at an elongation of 90 degrees, which means it's basically looking at right angles to the sun. So it's looking off in that direction. And so what it tends to find are objects that are in Earth-like orbits. So it tends to have a selection bias for the ones that are the most threatening and have very close encounters and potential impacts.
Interesting. Now, the fact, Dr. Boslough, that this one is traveling at the relatively slow speed, I'm going to put it in miles because most of us here in America think in miles. 31,000 miles an hour is only half Earth's orbital speed. So correct me if I'm wrong. That suggests that it's kind of catching up to us from behind rather than hitting us head on.
Right. So that speed you're giving is its speed relative to the Earth.
Right.
And I can see you've got the racetrack up on the screen showing this object in its orbit relative to the Earth's orbit, and it's going in a prograde orbit, which means it's orbiting, looking from the north. It's rotating around the sun counterclockwise. So it's moving in the same direction of the Earth, so it kind of sideswipes. If it were to hit the Earth, it would be kind of a sideswipe as opposed to a direct from ahead head-on collision. And therefore, the relative velocity isn't as high as its velocity relative to the sun.
Let me just pause you guys here for 1 second for folks joining us. This is a broadcast from Slooh.com. We are the community telescope. Our members are incredibly interested in what goes on in the sky, and our members have access to our Slooh observatories, one located in the Canary Islands with 2 fine telescopes, one located in Chile, our southern observatory, and we'll talk about why that was so important in just a few minutes. But if you want to make sure that you know about broadcasts like this one and others that we do, and of course they happen sort of sporadically because things happen in the sky sort of sporadically, come to Slooh.com and sign up for our free e-alerts, and we'll notify you when our next show goes live. There's absolutely no obligation and no cost. Obviously, we would like you to watch our broadcasts, and we hope you're interested. So go to Slooh right now, Slooh.com, and sign up. And then the next time we have a broadcast, we will make sure and send you an email to let you know exactly what's going on. Mark, what would happen if an asteroid of this size were to come to the Earth? I know this is actually larger than the Tunguska asteroid, we assume.
It's quite a bit larger than the Tunguska asteroid. My best estimate for that size was 40 meters, about 120 feet in diameter. But now these things scale. The energy scales as the mass, the volume, and that goes as the cube of the diameter. So when something, is 10 times as big in diameter as this, roughly, as this is relative to Tunguska, it's more like 1,000 times the explosive power. So where Tunguska may have been 3 to 5 megatons, this is, as I said, something like 2,000 megatons.
And
could
Mark,
be bigger.
Tell folks what the impact of Tunguska was.
Just the history of it, or the
what the impact of the explosion was.
Okay, yeah. So Tunguska was an explosion over the Siberian forest in 1908, and it knocked down trees over an area of about 800 square miles. It's a Siberian pine evergreen forest, and it just laid the trees down over this huge area that's bigger than the Washington, D.C. metropolitan area. So it did an enormous amount of damage. Most of it was from the wind The blast wave is so strong, it's a shock wave in the air, a strong blast like you would get from a large explosion, because it was a large explosion, and it was that blast that knocked these trees over. So you can imagine what damage it would do to a city. Now that one didn't hit the ground, or we don't think it hit the ground. There's no obvious crater there. There are some people who think that a nearby lake was formed as a crater and filled in with water. That a lot of us are very skeptical of that idea. So we don't think it hit the ground, but this object, 2014 HQ124, would definitely hit the ground, but it would also create an enormous blast wave, very much like Tunguska, over an even larger area.
Bob?
Well, okay, I have a question too, and that is, since asteroids, near-Earth asteroids, and these objects tend, as Dr. Boslough just mentioned, to orbit the sun, they orbit the sun in the same direction we do, counterclockwise, when you're north of the solar system. Obviously, something orbiting in the opposite direction, and comets have more random orbits, could hit us head-on as debris from, for example, that we see in the Perseids every August 11th, and the Leonids when we get those on November 18th. Those are much, much, much faster. And since, as Dr. Boslough has pointed out in past shows, the impact varies directly with the mass, but also with the square of the speed. Speed is very, very important. So my question is this: would it be worse to have a flimsier object like a comet, but moving at a faster speed, since comets can hit us head-on, and these tend not to hit us head-on? So are you more concerned about comets or asteroids?
Well, there's multiple parts to that question. For a given comet, if you had a comet, say, that was the same mass as this asteroid, but it was coming head-on, then I would be much more concerned about that comet, because, as you said, the amount, the energy associated with the impact, which is what causes the damage, that goes as the square of the speed, and a comet could be coming 3 times as fast, so that would be 9 times as much energy. So it would be a much bigger explosion, much bigger crater, much more damage. But that said, I'm more worried about asteroids than I am comets, because there are so many more asteroids. The likelihood of an impact from an asteroid is probably 100 times the likelihood of an impact from a comet of the same size.
And this is a perfect time then to play that little piece that we wanted to use before from David Morrison, because talking about probabilities, which is something that astronomers and astrophysicists do all the time, doesn't necessarily give you the full story. Listen what he had to say.
In the end, what counts is not probabilities. Ed Luke can say there's a probability, a 30% chance in the next century, and that's good to know.
Okay.
But really, what people want to know is not the probability. They want to know, is there a specific object? And where and when will it hit? We're not doing statistics.
Okay.
We're trying to find and predict an individual impact so we have enough time to respond to it, whether by evacuating the ground zero area, or ultimately being able to send a spacecraft out and deflect the object.
So basically, what Dr. Morrison was saying was, the probabilities don't make much difference if there's one there. This is, all hits are sort of anecdotal events, and whether it was just a 30% chance or a 10% chance or whatever, if that chance comes true, it's going to make it a very sad day for you.
That's right. I guess I would add, and I didn't hear Dave on my channel either, but probability is the best tool that we have. It's true that it's not the whole story, but it's really the only information we have. And in a way, it's like playing the lottery. You're very unlikely to win, but if you do, it's going to change your life.
Not sort of in the same way as the lottery, though.
Not necessarily, no.
So, are you involved with the with NASA's Asteroid Grand Challenge?
I'm not directly involved with that. No, my role is primarily modeling what happens when an asteroid hits the Earth.
But I suspect you're interested in what they're going to be uncovering, or at least trying to uncover.
Oh, absolutely, yes.
Now, the Slooh members have been asked to help out with things like trying to, in essence, recapture asteroids that have been left to wander on their own, and also to produce light curves to talk about the tumbling and the motion of the asteroids while they're in orbit. Are these important things as far as the impact of the asteroid to the, excuse me, let me start again, potential impact to a planet like the Earth?
The more we know about the properties of asteroids, the better job we can do calculating the effects of what would happen if they hit the Earth, and also the more we know about what we would have to do to deflect them or to completely disperse them. So if they were on a collision course, we could mitigate and keep it from hitting, or blow it up and keep the fragments from hitting. Those are really the two options.
All right, Bob, I'm going to let you wrap it up with Mark, and then we're going to take a look at some of the imagery that we've gotten from the Slooh telescope in Chile. Bob?
Okay. Well, Mark, it's always fascinating when objects come in from space and impact our lives. I think that's one of the big reasons that many Slooh members use the Slooh telescopes, because of this obvious connection. It's becoming more and more obvious all the time between space and our lives. Now, houses have been, and in some cases people have been injured. The most famous events there was the famous car that was damaged in Peekskill, New York on October 9th, 92. The homes in Wethersfield, Connecticut, damaged in 82 and 71. The woman who was injured in 1954 in Alabama, Silicoga, Alabama. These are famous events. My question to you is, the big ones, when we think of something that does a lot more damage, that is spectacular, that can be seen over a wide area, we now, of course, will always remember Chelyabinsk last year on February 15th, Tunguska a century earlier, back in 1908. But before that, we think back all the way to the KT extinction event that wiped out the dinosaurs 65 million years ago. My question to you, long-winded question, but my question to you is, before Tunguska and after the KT event, was there a major event that somehow has escaped the mass media notice, including mine?
Oh, absolutely. I mean, just statistically, and this is where those probabilities really come in handy. We can estimate how many impacts of a given size has happened since 65 million years ago, when the dinosaurs were wiped out. And so, we know there were a lot of events between then and now that weren't recorded in the geological record, or they were recorded, but their record has been erased. Either they, splashed into the ocean, maybe made a crater in the ocean bottom and the ocean floor, but that crater has been subducted. It's been pushed underneath the continent, so it doesn't exist anymore, or it's hit on land, but it was completely eroded. So, there have been lots and lots of impacts that are no longer exist in the geological record, but we know they had to happen, just because we know, well, for one thing, we know there are a lot of craters of that age on the moon. The moon has a lot more craters than the Earth does, because the moon's surface doesn't have the erosion that the Earth does. Right.
And of course, I've heard this too. There's Chelyabinsk, there's Tunguska, there's the KT event, and then in between them, there are a lot of things that must have happened. But I wondered if there are specifics. It seems like here's two big headline-making events in a single century, 1908 and now 2013. Before that, 65 million years ago. Is there nothing that Europe or the colonists or anybody noticed or noted in between? There doesn't seem to be.
Well, there may be. I mean, people have tried to interpret old historical records and ancient myths as evidence or events like this. And it's possible that they could be, but when you think about it, if Tunguska had happened a century before it did, there wouldn't have been anybody who observed it that would have had written language. And likewise with Chelyabinsk, most of the Earth, even now, isn't highly populated. The reason we know about these is because we have remote sensing now when they happen off in the middle of nowhere. And these things do happen out in the middle of nowhere, and nobody reports them. Nothing as big as Chelyabinsk, but we have had explosions, 10 kiloton Hiroshima-sized explosions that have happened way out over the Pacific Ocean, and little or nobody observed them, but they were observed by satellites or observed by infrasound, very low-frequency sound detectors. If they'd have happened 100 years ago, nobody would have written it down or reported it, or possibly not even seen it.
I see. And if nobody observed it, then one could ask, did it really, does it happen if nobody's watching?
It's kind of like the tree in the forest.
Yeah.
Hey, Mark, thank you so much for taking the time to spend some time with us today. We very much appreciate it. That's Mark Boslough, who is from Sandia National Labs and is an expert in the potential impact of asteroids and the Earth. And we thank you for joining us today, Mark.
Thanks for having me. I'll sit back and watch the rest of the show now.
All right. And
Okay.
by the way, if you would like to be tipped off to when we are going to be broadcasting, because obviously some of our shows can't be planned too far in advance because we literally don't know about what's going to be happening that far in advance. You can get breaking news alerts via email from Slooh. You can sign up for the email alerts right now at slooh.com. And also, for our Slooh members, we should remind you that there's always a lot of activity going on in the Slooh Clubhouse. And for those of you who are not Slooh members, behind our little gated wall, not only do we have access to the 2 Slooh observatories, 3 Slooh telescopes, but also a very active community of discussions between like-minded people who are very much interested in what's going on in the sky and who are the people who guide our Slooh missions. All our Slooh members get slots that they can program to tell our telescopes where to point, their own individual missions. So you decide where the Slooh telescope points. And all of this, by the way, is available for you to look at and see and find out about at our website, slooh.com. Let's invite in to join Bob Berman and me, Paul Cox. Paul is our observatory director from Slooh. It's interesting, Paul. We had been having some problems recently with the observatory in Chile. It has just come back online within the last few weeks, and this is actually good because without the Chilean observatory, we couldn't see this object in the sky. Why is that, Paul?
Well, good evening, Geoff. Hello, Bob. It's because this particular asteroid is staying incredibly far south. It's very close to the sun from Earth's perspective. So you have to be in the southern hemisphere, like the Slooh Chile Observatory, or where our live feed is coming from today, in Australia, to be able to see this. Now, I don't know if you know, but this asteroid is actually making its closest approach on the 8th. So that's the night of the 7th. But nobody is going to be able to observe it when it's making its closest approach to Earth. We lose sight of it entirely. Well, this particular asteroid is called an Aten-class asteroid, and that Bob can tell us a little bit more about that, but it basically means that it stays virtually within the orbit of Earth, so it's always very close to the sun from Earth's perspective, which means people don't want to point their telescopes in that direction. And that's why NEOWISE, the WISE telescope, is so important, because they can reach these areas which Earthbound telescopes can't, Geoff.
Well, it's fascinating. Fascinating. A few moments ago, Geoff mentioned that we have like a little almost gated community here. I always thought that those were called gated communities down in Florida because there's so many alligators and a lot of them, bothering people playing golf and stuff. But I guess I just learned something. They're not really gated communities, are they?
No.
Okay. Another observation is that it's interesting that we just had Dr. Boslough on, who's an expert on impacts. That's his thing, you know. And many of his analogies involve how many megatons, how many H-bombs worth of a blast there would be if the one that we're observing, HQ124, were to hit us. And interestingly enough, who does he work for? Sandia Labs, which, in case you don't know, they're the most famous for manufacturing H-bombs. So there's just great irony everywhere, just in all of this, including the fact that we keep being missed by these asteroids. So that
don't complain about that.
But we're not. That's the whole point, gents, because I often get people coming up to me saying, hey, listen, Paul, love the shows, and we've been doing them for years now. We've done Tutatis, Apophis, LZ1, who can forget DA14, all of these asteroids. And they turn around to me and say, listen, why do you always show this thing? You miss it. They always miss it. Slooh members back in 2008, we imaged an asteroid 2083, just hours before over the skies of the Sweeney Earth. Also, in 2012, we were in the month of last year for the public every single night. An impact on Jupiter at 7,000, an unknown object, an asteroid or comet, so slam into Jupiter's atmosphere. And so you say, well, that's Jupiter, doesn't it? Cleaner, blah, blah, blah. Well, also images from Mars which show Jupiter being formed there with asteroid impact. We've done fantastic images that just for the last couple of years. And the last example, Geoff, is back the first asteroid that is discovered this year, 2014, AA, impacted the Earth. It wasn't a close flyby, the Earth, and no one was looking at it. It was discovered a few days before, and then it went unobserved. And that's what we're trying to do at Slooh. We are trying to mobilize an army of citizen astronomers, teach them how to observe and monitor these objects so they don't get lost. It's really important.
This is the perfect lead-in, Paul, because Slooh is participating with NASA in the Asteroid Grand Challenge. And when I spoke with David Morrison a few weeks ago, I actually asked him exactly what NASA and their community would like to see from our Slooh members. And here's what he had to say.
It would really be great from NASA's perspective if the members of Slooh and other amateur astronomers would try to get involved with helping us protect our own planet from incoming asteroids. Now, in most cases, we don't think there is an opportunity for amateurs to find objects, new objects, because they're so darn small, the ones that we haven't found. But once the professionals have found an object, then the amateurs can help in two ways. One, they can help in tracking it so we get a better orbit. And second, they can make physical measurements like a light curve showing the variation of brightness with time, or perhaps even the color, depending on their equipment, that would give us some hint of what the object is, how big it is, how fast it's rotating. I think the rotation issue is probably the biggest open issue. For really small asteroids, we think they rotate very fast, just in a few seconds, but we don't have much data. And so if an object is found by the professionals, and it's very close to the Earth, so it's bright enough to be seen in the Slooh telescopes. It would really be great if those telescopes would be used to observe that object and, for instance, obtain a light curve showing how it rotates.
And so that's why, and that's how, Slooh members can help in the search for asteroids, and also to find out a lot about what's going on as far as their motion while in orbit. Again, for those of you just joining us, this is Slooh. Slooh is the community telescope. Now we have a little problem here because we have a microphone on, There it is. It's off now. Okay. Slooh is a community telescope, and our members can point that set of telescopes, actually 3 of them, one in Chile and 2 in the Canary Islands, and send it on missions. And of course, our members meet and trade ideas and thoughts in our Slooh clubhouse, which is located at slooh.com. So there's a lot of activity going on here, and what you're looking at right now is actually coming to us from Australia, from Brisbane, Australia, the Samford Valley Observatory. Our thanks go out to Jonathan Bradshaw, who has provided us with these pictures. The problem that we have, we can image this from our Chilean observatory, but it's daylight right now, right, Paul?
That's right. I mean, we have been imaging it. Slooh members have been imaging the asteroid every clear night for the last week or so. And actually, we've got some time-lapse animations that we've made from those images. And Slooh members, as part of their involvement with the Asteroid Grand Challenge, have been performing what's called astrometry on those images. And that helps the Minor Planet Center to accurately determine the orbit of these objects, Geoff.
Explain astrometry, please.
Well, astrometry is basically measuring the position of an object in relation to a known star field. So if you look at these live images that we've got coming in from Australia now, most of the white dots that we see there are stars, and their position is known incredibly accurately by a number of surveys that have gone over the whole sky. But obviously the asteroid is moving against that background of stars. So if you know the precise time of an image, Geoff, you can measure the position of the asteroid against the background stars. And if you get a few of those measurements, you can then start determining the orbit, the 3-dimensional orbit.
And the fact that we now have our Chilean observatory back online, Bob, that's a big deal, right? Because there's just so much that there's so much that we can see from our 2 Canary Island telescopes, but being in Chile opens up whole new horizons, right?
Oh, absolutely. And don't think that people in the clubhouse are all kind of on bummers and saying, oh, an asteroid's going to hit us. When is the next asteroid? You know, this is actually a very upbeat thing. Not everybody's looking. This is fascinating to look at these moving little points of light because they're alive, they're dynamic, they're just barely missing Earth. And, that's great. But especially down in the southern hemisphere, we can see things we cannot see from here. The Slooh members using Chile are viewing objects like the breathtaking 2 top globular clusters. These are cities of suns where you have 1 million suns packed into a ball, 47 Tucani and Omega Centauri. There's nothing better. And 2 of the finest nebulae, birthplaces of new baby stars, the Tarantula Nebula and the Eta Carinii. These are also seen from there, not visible from where we live here in the United States or in Europe, or even from the Canary Islands. So yes, this opens up a whole new vista of objects that we're thoroughly enjoying at Slooh.
Geoff, can I add
go ahead,
something here, Geoff? As Bob says, not all Slooh members watch asteroids. We've got comet hunting groups who do a fantastic job. Hey, by the way, there's some fantastic comets visible right now that they're monitoring every night. But Bob said, a lot of members just use the telescopes to image these beautiful, beautiful objects. And the southern skies are known to be very, very rich. But for those people who are studying asteroids and comets, there's one really important factor in all this, and that is the world's telescopes, the vast majority of them are located in the populous northern hemisphere of the Earth. So these objects actually go in the southern hemisphere, just like this asteroid that we're looking at tonight. This is a potentially hazardous asteroid 2014, HQ124. This isn't being observed very much because there are far fewer telescopes in the southern hemisphere, Geoff. So that suddenly opens up not only half the sky, but actually half the sky that goes very much under-observed.
Now, Paul, the animation that we're looking at in the lower left-hand side of the screen, that was produced by you, as I understand it. Is this the kind of thing that our Slooh members could actually do on their own with our observatories?
Absolutely. Several of these images. This image, it's a time lapse made up. I can't quite see which one this is, but it's probably over a few hours. So I scheduled some of those missions, but Slooh members scheduled the others. And everybody, all Slooh members, were watching these missions live. So we were actually watching these as they come through. They come through real time up to what we call the mission interface. And anybody can snap those images and save them to their own private collection. And then we've got a group in our new clubhouse, which is all about time-lapse and creating time-lapse animations. So in there, we're telling people, we're explaining to people how they can take that series of images and put them into a time-lapse just like this, Geoff.
All right. So for those who don't know, and I don't want this to be a sales pitch for Slooh, but I do want to explain some of what our members do because it's really fascinating. I mean, we give people the opportunity to do certain things that they just could not do on their own. First of all, you access our telescopes over the internet, and you can get a number of different types of files back, including a FITS file. Paul, that's really important if you want to use your imagery on a research basis, right?
That's right. I mean, there are two levels of data that people can get. One is the real-time Slooh patented processed color images. So you sit there and you see the color images forming in front of you. We're the only people who do that live. And you can point. You can choose where the telescope goes to get these images. Absolutely. Any object or coordinates in the sky if you want. So if you're one of these people who believes in this mysterious planet X, well, you can point the telescopes to where you think it is. And then you don't have to ask other people for proof. You can see that it's not there. That will wind a few people up. But yes, Geoff, you're right. There's this other type of data as well, and it's what our CCD cameras, these are scientific instruments. It's the kind of data, the images that they generate. And those are really important for two types of members. The members who want to use those images for science, for astrometry, photometry, but also those members who want to process their own images, their own astrophotographs, so they can choose either. So you can go in, you can just select from a list, or you can go in there, select your own coordinates to try and hunt down one of these asteroids or comets. And, so many times we've all seen these beautiful Hubble Space Telescope images, and what a lot of people don't realize is these oftentimes use false colors to try and bring out detail that wouldn't normally be seen. When you have this FITS data, you have the ability to go back in and manipulate and make things a little bit easier to see with false colors, right? Absolutely, you can do. You can certainly do that. But the other thing that people don't realize is that even with an enormous telescope like Hubble, most of those fantastic Hubble images you see have taken hundreds of hours of exposure time. And at Slooh, we've got these highly sensitive cameras. We've got the half-meter telescope at the High Altitude Observatory in the Canary Islands, and they create stunning color images within 5 and 10 minute slots. But Geoff, what people can also do is they can gather up that data from several of their missions of the same object and combine them, and that really, really starts to enhance the images even further. And we're a community, so if Paul Cox is looking at something, if you have a mission time assigned to you so you can point the telescope, all the other members can see that too, right? Absolutely, and tonight, in fact, I want to warn Slooh members, Chile Observatory, just before dawn, which is about, I think that's about 6 a.m. Eastern time, I have scheduled a whole bundle of what we call missions to this very asteroid that we are seeing live on our screens at the moment. So we're going to be, Slooh members are going to be watching this asteroid all night as well, Geoff. All right, and just to update those of you who have joined us in mid-broadcast, we're on today because of asteroid 2014 HQ124. It's about 1,000 feet in diameter, or about the size of a Nimitz-class aircraft carrier. It is going to be coming reasonably close to the Earth within
Bob, is it within about 3 lunar distances of the Earth?
Yeah, which is less than 1,000,000 miles. In fact, it's close enough. Here's a little fact. Paul loves the little facts I come up with, so I'll do this for Paul. This is coming within the distance of Earth's shadow. So if it were in the correct direction, our shadow would hit it. That's how close it is.
And how far away is it now, approximately?
Well, now it's 3 days beforehand, and I know a lot of the people that are watching this is because when they hear about a large object coming this close to Earth, they think, well, maybe the government is hiding it. They're not really telling us. But I assure you that, although I'm a little suspicious because Paul was telling me about that, he was watching Planet X a few days ago. Now suddenly on the show he said that if people look, they'll see it's not there. So I think that check that you got from the feds, from the federal government, Paul, may have...
You didn't get yours?
That is actually making the news. I just came to see that people think that in about a month we will be slammed into by a Planet X. So additional reason to...
Now don't get people worried about that.
It's a reason to join Slooh because now you can look for it independently. We don't block the telescope except for certain parts of the sky, Paul, that Paul has started blocking. But other than that, you can really point it anywhere you like.
Well, Jens, there's a very real connection to what we're looking at tonight. This asteroid that we're looking at tonight, as you guys have already discussed, was discovered by the NEOWISE, the WISE Space Telescope. And in fact, very recently, I think it was only earlier this year, that same telescope has been used to virtually rule out the existence of Planet X. They went for a specific hunt on it. And don't forget, this telescope, infrared telescope, it's designed to look for very dark, very cold objects.
And by infrared, you mean it's instead of looking for light, it's looking for heat?
Yeah, it's just looking for light at a different wavelength.
Yes. Actually, a lot of people are, I won't say confused about it, Geoff, because that would be not fair to you to say that, but there is actually a difference between infrared and heat. And it's interesting enough to make the point, since the object we're looking at right now was discovered because of its infrared emissions.
They are not analogous?
No, they're not. As Paul pointed out, infrared is a form of light whose waves are just longer and less frequent than visible light. What it does when infrared waves hit your skin, it makes the atoms on your skin vibrate or move, and it's the motion of the atoms which is the heat. So it produces heat on an object that it hits, but it's not heat in and of itself, because heat is simply the movement of atoms. And infrared, it does not involve atoms itself. It involves electromagnetic energy, a form of light.
Okay, and we're going to have someone join us right now. And this is Jonathan Bradshaw is on with us now. Jonathan's from the Stamford Valley Observatory in Brisbane, in Queensland, Australia. And good morning to you. It is very early on Friday morning in Australia. Am I correct? Are you there with us, Jonathan? It is so far that he can't hear us. Well, Jonathan is directing our feed this morning, which we very much appreciate, from the Stamford Valley Observatory. You know, as long as we're talking observatories, Paul, you are our Slooh Observatory director. Can you just give folks who are joining us just a really quick rundown of what kind of hardware we have in the Canary Islands and in Chile?
Yeah, certainly. Members are always interested in this, and we often get asked these questions. Indeed, if we do get Jonathan on, we've already had some questions in the clubhouse from Slooh members asking what equipment is he using. But anyway, Slooh's observatories, if I talk to you about the Canary Islands Observatory first, it's 8,000 feet up on a volcano, and it's in that lovely smooth air that crosses the Atlantic Ocean. So our domes are up there. We've got 2 domes, and in those 2 domes, one of them houses our fantastic half-meter telescope. In the other, we've got a 14-inch telescope. That's our planetary high magnification telescope with a wide field on top of it. All of those use scientific-grade CCD cameras. These are... ultra.
Just to put it in perspective,
Yes.
a typical backyard telescope that somebody might get, how does this compare in size and in its ability to see?
If you've got a backyard telescope, if you've got a really good backyard telescope, you're probably talking something about, 10 inches in diameter. But what makes it really special is the CCD cameras that go on the back of it. These are these highly cooled, they cool down the chip to minus 50 degrees centigrade below ambient temperature, which cuts out all the noise. They're really sensitive. We've got fantastic filters, and that's what really gives you the ability to hunt down these really faint objects.
And in Chile, what do we have?
We have a very similar setup to the high magnification telescope in Tenerife. So it's a very similar system, which is actually quite good for members because they can take images using both of those systems and compare them quite nicely.
All right, and we are now being joined by Jonathan Bradshaw. Before I go on, just prove you're here, Jonathan. Say hello.
Hello, guys.
Hi,
Jonathan.
He is here, and it is the wee small hours of the morning where you are in Queensland. Some of our members in the Slooh Clubhouse have been asking what kind of imaging equipment we're using from Samford Valley to provide this live image that we're seeing now. So why don't you let folks know?
Yeah, absolutely. Now, I've been doing astrometry and occultation work for asteroids for about 8 years now. So the setup I've got is very specialized to do this particular job. But it's still made of just standard off-the-shelf components from the big companies. So what I'm using is a 14-inch Meade Schmidt-Cassegrain. So it's the biggest practical Schmidt-Cassegrain telescope you can get, and they do go bigger, but they just get humongously heavy after that. And in order to get...
Can we judge the size of the telescope by what your wife said when you said you were going to get it?
Well, one of the advantages of I'd already had a 20-inch Dobsonian, which had caused a few eyebrows to raise before I got the 14. So that was actually stepped down in size. So I got away with that one all right.
And tell us where you are. You're not actually in Brisbane. I would assume that in the city there would be much too much light.
That's absolutely right. I'm about 14 miles out, 25 kilometers outside the CBD. Australia is still pretty lucky. It's all of the cities are very leafy. There's lots of trees. They block out the light. So the actual light domes that come from the cities are much less than they are certainly where I originated from in the UK. So even from relatively small way out of a very large city, I can get a pretty good sky here. I can see, we can image down to 18 magnitude potentially at a push.
And what would you say the magnitude of 2014 HQ124 is now?
It's at around 14th magnitude.
14, yeah.
And that's a really good. That's where the amateur range comes in. So even with a 10-inch scope, as you mentioned earlier, 14th magnitude is very, very achievable. And below that, so some of the objects are much brighter. I must add that this scope is not running a native focal length. It's using the Hyperstar system to take it down to f2. And that allows me to get what you're looking at is a pretty wide field of view. It's actually nearly half a degree across. And I'm using the opposite, the antithesis of a normal camera for astronomers. I'm actually using a camera that you'd normally see in a car park. It's a security camera. The reason I use that is from a bang per buck perspective. A security camera, they're specifically designed by people who want to see objects in moving objects in faint places, as in underground car parks. They're incredibly sensitive, so I can do an awful lot of asteroidal astrometry and measurement just using a relatively cheap device.
Yeah, it's fascinating. And by the way, we thank you so much for giving us us access to your imagery today, because it has made telling the story of this asteroid that much more impactful. Maybe that's a word I shouldn't use with asteroids, but it has, and we very much appreciate you giving us the feed, because we certainly wanted to show it today. And though we can observe it with our Chilean observatory, the problem is that Chile is in the sunshine right now, and that's going to make things very, very difficult. By the way, we had it up on the screen before. Let me just mention that if you would like to be informed when Slooh has these broadcasts, when there are events going on, and we cover comets and asteroids and meteor showers and many discoveries in the night sky, many discoveries that have been helped along by our Slooh members. We will send you emails. Just go to our website, slooh.com, and you can sign up for free to get breaking news alerts from Slooh. And as long as you're on the website, take a look around and see what we do there. Now, you won't be able to see everything we do, because in order to keep things sort of orderly, we keep our clubhouse for members only. But there's a lot going on at Slooh, and if you're interested in the nighttime sky, if you're interested in astronomy or astrometry, if you're interested in meteors or planets or asteroids or looking at distant galaxies, we are the place to go. You can find out more at our website, slooh.com. Gentlemen, I think we're going to wrap it up here within the next few minutes. Let me just go once around the block and see if you have anything that you would like to add. Jonathan, before we let you go, is there something you'd like to say specifically about 2014 HQ124 that you have found interesting as you've tracked it?
I mean, these objects are interesting. This is fascinating to be involved with an object which is quite so large and has been known about for quite so little a time. It really underlines the work that it is outside the range of amateurs to pick these objects up. They're too faint when they're first discovered, but it's just so important to be out there looking so that we can then get to follow them.
And I assume, by the way, I haven't asked you this, will you be participating in NASA's Asteroid Grand Challenge?
Well, I have my own observatory code, and fun enough, I've been participating in NASA's Grand Challenge for several years before it even existed.
Oh, okay. And of course, our members have been encouraged to use their time, if they so desire, to help out NASA with the Asteroid Grand Challenge. We have some videos about that and some more information on the Slooh website. Bob, let's go over to you and get your final thoughts today.
Well, very exciting. Always is when we have a asteroid going by. This has an awful lot of 1s, 2s, and 4s in the number. I think that's very suspicious. But much less suspicious will be the honey moon. And that's coming up, a very unusual full moon coming up next week on Friday the 13th, when we're going to have the lowest, most orange, most amber moon of the year in the sky on a Friday the 13th. And what does that mean? We're going to be covering that live.
All right. And Paul, I know that you're very happy that Chile is back up and online and imaging. Why don't you put a little final wrap on this today?
Well, I'm just going to remind Slooh members, have a look at the Chile telescope later on tonight, because we are going to be watching 2014 HQ124 as it gets even closer to Earth. I'd also, Geoff, like to thank Slooh members, because it's them who make our live programming possible. And also huge thanks to Jonathan Bradshaw for providing these fantastic images tonight. I've just been watching that tiny little asteroid move across this frame. It's been fabulous to watch. So thank you, Jonathan.
When you think about it in perspective, we think of it as big if it were to hit the Earth. But this is the size of an aircraft carrier, and we are looking at it from approximately now. Is it around 1 million miles away right now, somewhere in that range?
It's a bit
closer
further away
now?
than that. No, it's at nearly 2,000 miles, 2 million miles. At its closest on the 8th is going to be 777,000 miles. So it's still got a long way to come. between
But this
now
is
and
a tiny little object in the deep vastness of space.
It's extraordinary, isn't it, that we can see this and all of us enjoy this from around the world live tonight.
Yeah, it's incredible. Well, listen, thank you all for joining us. Again, thank you so much to Jonathan Bradshaw. Thank you to Michael Wilson, our producer at Master Control in Hartford, Connecticut tonight. And to all of you who joined us, of course, we're very proud of what Slooh does, and we know some of you might want to find out more about it. Please come to our website at slooh.com, take a look at our videos and scout around, and of course, sign up for our free e-alerts. I am Geoff Fox, and thank you for joining us today from slooh.com.